Okay, so what is different about this one, this last little section than the one before is, we were strictly calling out the answers as they were defined, as the function was defined. This is different in that they asked us to call out the answers over this interval. So whereas we might have found the inverse of sine to be something like negative pi over 4. Well, we would not call that as an answer. We want to call out all the answers in terms of between 0 and 2 pi. So our answers are going to change slightly. I'll show you how this goes. We're keeping with the convention that x means radians and theta means degrees. So number 10, we want to find the arc sine of square root of 3 over 2. We ask ourselves where between 0 and 2 pi on the unit circle is the sine negative square root of 3 over 2. So it is right here, right? This is where it is, but it's also, where else is it hitting this high sine value of square root of 3 over 2? There's another angle right there where that happens. So you can look at your unit circle to get your answer, and it will turn out that these two answers here are when x is equal to pi over 3 and 2 pi over 3. All right, let's do number 11. Number 11 is the inverse cotangent of 1. All right, but that's wherever the inverse tangent is 1 over 1, which is 1. So where is the tangent equal to 1 on the unit circle? So the tangent is equal to 1 where the sine and the cosine are the same value and the same sign. That happens in quadrant 1 and in quadrant 3 right here. So there's two places. What is this? This is at pi over 4, and this one over here is at 5 pi over 4, because the sine and cosine are both 1 over the square root of 2 in quadrant 1, and they're both negative 1 over the square root of 2 in quadrant 3. So our answers are going to be pi over 4 and 5 pi over 4. All right. How about the inverse secant? Okay, well 12 is, this is where the cosine inverse of negative square root of 3 over 2. You take the reciprocal. Ask yourself, where on the unit circle, I just realized this was theta, so I don't want to call out radians, I want to call it degrees, that's fine, but where on the unit circle is the cosine negative? Well, in quadrant 2 and 4. So where is the cosine negative square root of 3 over 2? Right here. And there's another place it's going to hit right here. There's two of them, right? What are these two angles? This one is at 150 degrees. And this one is at 210. So the reason I called out degrees instead of radian is because of that theta as opposed to x. That's just a new convention we're getting used to. 210. Alrighty. Arc cosine of 0. Where is the cosine 0? The cosine is 0 here and here. And what are those? 90 degrees and 270 degrees. Very good. All right. Now let's do this next set of problems. These are different in that we are not familiar with these. I don't see those on our unit circle, so we'll be using our calculator to figure these out. So the first two are theta, so that means we want our calculator in degrees. So this is degrees. These two are in x, so we want our calculator in radians, and this is how we do that. I'll use my calculator here, and I'll say the secant inverse. Okay, this is equivalent to the cosine inverse of 1 over 2.712. Okay, these are a little bit, you got to think about them a little bit just because they're not on the unit circle. So let's do this. Let me check my mode. And my mode is in degree right here, so that's good. I'm ready to go. So then I'm just going to say the second cosine inverse of 1 divided by 2.712, and hit enter. I get my answer. And so this tells me this is true when theta is 68.4 degrees. However, if you look at the problems we just did, we found 2 places on our unit circle where that happened. So this is positive, right? Where is the cosecant, the secant and the cosine positive in quadrant 1 or 4, right? So we've got one angle here at 68.4 degrees where this is true. We're going to have another one here where it's got the same cosine value. All right, how can we figure that out? Well, if this much was 68.4, then this much is 68.4. The name of this angle would be, we could find 360 minus 68.4, and that would give us that one. It's this guy right here. So 360 minus 68.4 would give us this guy. So if I just say minus 360, that's going to tell me this other angle is 291.6 degrees. So these are my 2 answers here. Now we could totally check this. We could take the cosine inverse of these, right? Take the cosine, or we could take, we could take the, if we take the cosine of this angle and then take the reciprocal of that, that will tell us the secant and we'll get this number back. So we could take the cosine of 68.4 and then take its reciprocal, and that gives us 2.716, which is close because we did, that counts because we just didn't take it out a lot of places. Let's do that again. Let's take the cosine of this other one, 291.6. Okay. If I take 1 over that, I get the secant. And that gives me 2.716, which is as close as we're going to get for the amount of digits we took it out. And so that is a way to check that. All right. Let's do the next one. The inverse cosecant of 0.25. This is equal to the sine inverse of 1 over 0.25. So we'll do the inverse sine of 1 divided by 0.25. And that says error, and that is correct because 1 over 0.25 is really 1 over 1/4, which is really sine inverse of 4. And that is outside the range of sine inverse, and so this one is a does not exist. All right, so that's that one. Let's do arctangent, but these are in radians, so I want to switch my mode to radians. All right, let me see. Okay, now I'm in radians. Okay, so let's take the inverse tangent of this. So take inverse tan of 1.77. That gives me this angle of 1.06. Okay, so x is 1.06. Now, there are 2 places on the unit circle where we're going to get this tangent value. X is 1.06. Let's just say it's there. This is where the tangent is positive, but it's also positive in quadrant 3, 180 degrees off from that. So I got 1.06, but I'm going to add pi to that and get the second angle. So 1.06 plus pi. 1.06 plus pi gives me 4.20. So my answers here are 1.06 and 4.20. All right. Here is the cotangent inverse, and it's negative. And so I remember that when the cotangent inverse is negative, since I used the tangent inverse to get there, I got to add pi or 180 to it. All right, here we go. This is equal to the tangent inverse of 1 over negative 1.558. I'm going to start with that. It's going to spit out a radian answer. So let's do that. All right, so inverse tangent of 1 divided by negative 1.558 gives me this. All right, negative 0.571, or I'll just say 0.57. Okay, so where is this? Well, I was a little bit wrong. You don't have to go strictly by this. What we really need to go by is this. between 0 and 2 pi. So that's really what I should have been saying. So negative 0.57 is not in this range. So how do I find something coterminal to that? This is where we'll just illustrate it being negative 0.57. You can add 2 pi to that. So let's add 2 pi to that, and it'll be coterminal. Plus 2 pi gives me 5.71. Okay, so this is 5.71, and this is within the 0 to 2 pi. But we think there is another one that is 180 degrees off. So we got to think about this. If from here to here is 0.57, I didn't draw that very good. Let me draw it better. Sorry. Let me try again. Here is my circle. I did the calculator. I found out negative 0.57. So if I use a straight edge, that will help me. So negative 0.57, let's say it is here. All right. We know that 180 degrees off from that, there's another one. So this is negative 0.57. That means this much is negative 0.57. How to get this in the range between 0 and 2 pi, to get this angle right here, we had to add 2 pi. That's coterminal, and that produced 5.71. How do we get the second angle right here? It's a little bit bigger than pi. Well, this one's going to be pi plus 0.57. So let's do that. Pi plus 0.57 gives us 3.71. So these are my two answers here. 3.71, 5.71. Is that right? Yeah, okay, I'm okay with that. Let's see, 0.57 plus pi. Okay. All right, so let me check this. Let me take the tangent of this, or the cotangent of this, and I want to see if I can get that. So, to find the cotangent of 3.71, yes, something's not right here. This, I'm so sorry. That's not right. That is not right. This is right. This is right. 5.71 is right. I was looking at the wrong thing I drew. So let me highlight it so I don't do that again. This, the top line is what I'm trying to highlight. So this is the other angle. So 180 degrees off. This is the x-axis. This angle is this much. So I need to go pi minus 0.57 will give me that one. So let's do that. Pi minus 0.57. And that is 2.57. 2.57. So you can see it's a little bit, you got to think about it a little bit to get the right angles. But you can check. So let's check this, okay? And remember, it won't be exact because I didn't take it out a lot of places. But let's take the cotangent of this and see if we get this right there. So take the cotangent. This is my check. And you can do this on all of these. The cotangent of 2.57. And then take the cotangent of 5.71. And we want to make sure that it equals this number in here. So how do we take the cotangent? Well, first we take the tangent of that. 2.57, and then I take 1 over that, which I just hit this x to the negative 1 button, and I get negative 1.55. That 8, this is a 4, but that's close enough. That feels good to me. Let's do this one. Take the tangent of 5.71, and then take the reciprocal, and you get negative 1.55 about. So that is also ballpark. That works for me there too. So you can check these. That's how we'll go about finding those values when we have an interval to go between.